Right, there we are. And Rod showed you just now this sunspot picture, so I'm going to fill in really how I did that and what you're actually seeing, plus some other bits and pieces which we might get to. So anyway, it's to do with this camera. I've had it a year. I finally pulled my finger out and got it working. Oops, let's go back. Hang on. Right, there we are. Right, go forward. This is the sun a couple of weeks ago. There were 9 sunspot groups at the time, and clouds, of course. Well, this is just with the handheld camera through the eyepiece with a Herschel wedge. You're never going to see an awful lot of structural detail, but there's something going on. But to move on from that, here is the 6-inch Maksukov underneath, and there on the top is the Baader solar film, but not the usual one that you buy. This is the photographic grade, which lets through, I think, 16 times more light than the ordinary one, and you're not supposed to use it visually. It's fine for cameras, but it comes with all sorts of warnings, and I've stuck them on my thing here to make sure nobody does it by mistake. And this means you can have much shorter exposures without burning the camera out. And that was part of things I've done. So it's the camera is at the other end of the telescope. It's on this EQ5, which I've aligned in daylight simply by pointing it to the north with a compass. And that's good enough. It takes a bit of adjustment, but really that's enough. So none of this alignment malarkey. Just to remind you about a sunspot, can I get rid of that? Okay. Sunspots, this is a diagram I pinched. They're usually often in pairs, and they're to do with magnetic flux coming up through the surface or through the photosphere, loops around and comes back down again. And when this happens, as it does, it disrupts the convection flow of heat at either end here, and means that the top here isn't as warm as the surrounding. So it's a bit cooler, and therefore it's darker. I mean, it's still very bright, but in contrast to the other one, it appears to be dark. And so that's the basic thing you'll see with the sunspot. Let's say often in pairs. So you'll also see, this is just internet pictures. There's the central umbra, dark bit, and then there's this outer penumbra, which has got this sort of fibrous texture. And then surrounded with that are these granules. These are little convection cells. And then occasionally and near the sunspot, you'll see dark, well, what look like dark granules. And these are really like micro umbra. That again is a magnetic flux thing, so the heat is not coming through, so they appear to be dark. They're called pores. Now, also, although it's not showing up on these pictures, you sometimes get light spots between the convection cells, where again some flux is coming up and material is coming up, but not really seeing those. Around the sunspots themselves, you sometimes see these bridges across the umbra, and these are called light bridges, and really they're to do with the thing disintegrating. The sunspot is falling apart, material is flowing over the top, and so you see it like this. Occasionally you'll see dots within the umbra dots they're called, and that's where the convection is beginning to happen. So it's not perfectly suppressed. These things are dynamic. Sometimes if the spot's going to fall apart, you'll see lots of bridges, and sometimes the spot will just change shape. So this is the sort of thing you're going to see. The granules around there, let's see the next one. Granules here, these are, as the saying goes, about the size of Texas, about 1,000 miles across, but they hang around for about 10 minutes, and they are, apart from the fact you can't see at the top there, in the middle of the granule is hot rising material, and then it cools down and then goes back down around the edges. And these things, they hang around for about 10 minutes and then they disappear. So they're constantly being turned over. Now, you can think of this as rather being like bubble wrap, but with the bumpy side upwards. So these bits sort of bulge upwards a bit. So like they do actually look a bit like that. Now, if you're looking from the side, coming in like this, you can see down into the valleys between the bubbles, and there it's a bit brighter there. And the result of that is that you see these. Oops. You see these faculae. This is where you always towards the limb where the angles are favourable, and you're seeing the sides of the convection cells. It's a bit brighter, and that's what you see, and you can pick those up. That's a better view of it there. I don't know, some Swedish thing. So that's what you're going to see. So can we see, or will we see anything like this? So I stuck my new monochrome camera on the telescope on Monday morning, Monday lunchtime, and before I did it, this was what the sun was like. There's this sunspot area here, which was interesting, and one over here, lonely one there. And in H alpha, not too much going on. The sunspot there, not too outstanding. But anyway, what would we get? Well, this was the first one. This is just after lunchtime on Monday. And it's about 150 frames all stacked up. It's the best 4% out of about 4,000, I think. Now, because the granulation is turning over all the time, there's no point in running the camera for, say, 10 minutes, because these cells are turning over in that kind of time scale. So a couple of minutes is probably plenty. After that, say the granules will start to blur. But you can see the granular texture very clearly here. And this fibrous sort of nature of the penumbra, that's come out pretty well. And then you'll see these light bridges here. So this spot here looks like it could be in the process of doing something, maybe falling apart or breaking up. This one here possibly breaking up as well. And quite a few of these pores. Now, these pores, they come and go. The sheer number of them tells you they're like sort of spare flux that's got away from the main bundles that are in the big spots. But they come and go in a matter of hours, a day. So you don't know if they're going to stick around, but the more of them there are, then the more complex the magnetism is. So anyway, that's Monday, yeah, about 2 o'clock. So I was delighted with that. You see it straight away on the screen. But the main problem is the seeing, as we'll show you. Right, this is the next day where I didn't frame it quite so well. And again, you can see all the granulation, irregular. The cells have come up really nicely. A lot of these pores are coming through. Again, these light bridges there. This spot here is developing somehow. This one, well, it seems to be breaking up, but there's a lot going on here. Now, these are the two main components. Between them is, well, still quite a few pores going on. So it's busy. Now, yeah, this is a close-up of the main spot, and you can see these little finger projections into the umbra. Yes, that's what you'd expect. This is quite faint ones, actually. But then again, that's some of them is the convection beginning to happen, and some of it is the material flowing in or across from the perimeter here, and it's the same over there. Again, you can see the granules quite clearly. Supposedly the granules get smaller around the perimeter of the spot, but I'm not convinced about that. Anyway, here we are. So this is Tuesday at the top. Yes, and Monday underneath. You can see in detail what's happened over the course of a day. It's hard to know if things have moved because actual references, but you can see that yeah, the pores rather are changing quite a lot. This component here is, well, seems to be breaking up, but the spot isn't really, it's just cooking. It isn't decaying, and it's not getting more complex particularly, and it's not getting simplified. So it's really just simmering. be the best thing to say. This is, when was this? Oh, this is today. Yeah, this is this morning. This is the best one from this morning at about 9 o'clock. Lovely detail, lovely development here. It's actually quite pretty, almost like an eye. Lots of bridges going on here. So this side is doing things, shall we say, although the number of pores seems to be fading away a bit. So it could be on the decay. That's another one from today, just same sort of thing, just to show you can reproduce it. Hang on, here's the close-ups again of the other. You can really get into the detail here. Now the next thing to do after having got this far will be to do some kind of time course or watch these things over the course of several hours, and that's the next challenge, I think. But for now, just looking at it. So here is Monday at the top. Go back. Sorry. Monday at the top, and today, Wednesday at the bottom. And you can see really that it's simplifying a little bit, but not hugely. So it's still simmering, and the area pretty much the same in total measurement. So this is an example of what's going on today. This is this morning at 9:16. Now the general rule is you do your solar imaging in the morning because the sun, the atmosphere is relatively stable. But later in the day, it's much more turbulent. And this is just nearly 3 o'clock. And it's much harder to get a good image here. I've had to correct, the noise has crept in because of the processing. But the seeing was nothing like as good mid-afternoon compared to early this morning. Everything is the same. I've focused it as best I can. But that's to show you that the seeing really does matter. And there are going to be times when you just can't get it. Which was the case this afternoon, but it was all right this morning. Here is a wider view. The camera's got quite a lot of pixels, so I can go across like this. There's a lonely spot down here. This is the one I've just been showing you. And then over here, out of the way, these people, is a spot that's just about to disappear around the corner. And when we look at that one, this is on Monday. You can see these faculae here, look at these bright things. So you're looking really at the edges sideways on of the tops of the convection cells there. And it always forms sort of channels and networks and things like this. The next day it looked like that, not as good, not as oriented in quite the same way. And today it looked like that. One of the spots was just left, that's all there is. The others are gone. But again, you can clearly see these faculae. So there you are. Oh, now just quickly, hydrogen alpha, because the camera, I've used it on that as well. This is from Monday, but this is my usual with the Pentax pointing down the eyepiece. So there's not too much going on according to that. And the camera is not modified. It's not terribly sensitive at this wavelength, but do what you can. But this is the view with the new camera. So one of the characteristics of the solar scope I've got is it doesn't really illuminate the whole solar globe equally well. So you have to sort of choose bits of it that are well defined. So over here it's rubbish, but here you can see what's going on. And the sunspot, although I haven't oriented it and flipped it the way I should, this is what you were seeing just now. And there's a filament coming out of it. So plasma is being ejected from the busy area between the two main components. That's where all the flux is going on. And the ultraviolet, of course, that's what you see much more strongly. That's where the flaring will occur. Here it is again, and you can pick up the swirls in the hydrogen here, following the flux lines pretty well. So it is rather like a magnet with iron filings appearance. There it is again. Again, you can see the swirling. Big, huge filament over here. Best part of 200,000 miles long. absolutely enormous. It's rotated, it's still there actually, it's rotated round, but it's quite something. This is the sunspot on Tuesday, and there's the Hadrian Alpha at the same, shortly afterwards, but the same day, and you can see how things correspond. But there's this filament coming out here. This is a lot of plasma being ejected from round about here, but of course it's going on above this, so you can't really tell from the white light that's what's going on. And this is a lot enlarged version of it, and that's the same thing here. This is today. Yes, this is today. So again, the filament here is a different one. They're coming and going all the time. Just there. The big ones stay put for days on end. But, there you go. And I also tried some prominences today, but that's much harder. The telescope really isn't much good for that. But I had a go. So this is a not particularly special prominences at all. But I caught this. This is yesterday at tea time, and yesterday I happened to notice a big prominence propping up there. Now this is with the DLSR. It's not with the battery camera, because I put it away. As luck would have it, this happened. And over the course of about half an hour, 45 minutes, despite clouds coming, it became really large, really prominent. This is so that's about 5:15. That's about 5:30. This is about 5:45, and it's beginning to fade away. And here, which you can't see because this is in the way, here you can see it's dissipated, and this is about 6 o'clock. So all in the course of less than an hour, 45 minutes. Now the strange thing was that today, when I was looking at about tea time, it happened again in much the same place. Now this is round the limb, so this is what's rotating away from us. We won't know if anything really is going on there for about a fortnight when it pops up over here, if it lasts that long. But just to show you how active the sun is, and things in Hadrian Alpha particularly change while you're looking. So if you go off and make a cup of tea or something, that's when you find that something happens. Always happens when you're not looking. And then finally, for this bit, if you're interested in solar astronomy, this book, which I've got a copy of, you can't get it on Amazon. You have to order it from the publishers. It's translated from the French, so it's not different from usual, and it's not cheap, about £60, but there's nothing quite like it. It's superb. It's not perfect. I've spotted some things in it that I would argue about, but it's a superb book. So if you really want to get into solar astronomy, this is the book to get. Now there is a review of this book in the August Sky and Telescope, but it's one of those ones where I read it and I don't think the reviewer's actually read the book. It's very much a summary, but there are things he hasn't picked up on, which I screamed out where I've read them, particularly some things about camera sensors, which I really didn't think were right, plus some things about tuning Hadrian Alpha. But nonetheless, it's not cheap, but there's nothing like it, and there won't be anything like it, I don't think, again, because no one's going to publish a competitor for this. So there we are. I think I'll close there. So I'll stop. Boom. There we go.
Well, we can give it a call.
Very impressive.
I'll see if anyone's got any questions, but if you don't mind, I'm going to press on because we've got a fair number of things to do, and perhaps we can time at the end if you want to ask John anything about solar imaging.
With those images of the sunspots, you said that it's very common for there to be two sunspots, and then you showed a diagram with the looping magnetic arc. what's happening with those sunspots that are just land? Is the magnetic field? switched
there'll be another component, but it won't have been, it won't be concentrated enough to form a dark sunspot, so it will be a more spread out thing. In the H alpha, you'd see it, you would see a brighter region, but because it's sort of the magnetic flux sort of spread out, it's not done enough to form a visible
Oh, I
sunspot.
see. So it's not strength of the field, isn't?
No, it is spread. I mean,
So-
if you can gather it all up into one place and plonk it down, yes, it would form another spot, but it's sprayed out. So you don't reach the threshold where you can see it. But I would say in hydrogen alpha, you almost always can see the partnering. And very often, like the one here, the hydrogen alpha action is going on between those two big components. That's where the flares are coming out. In fact, there was a flare going on at tea time, which I could see. And in ultraviolet, which of course you can't do at all, that's where you see all these loops and
Yeah,
the energy. It's a hell of a lot of energy in there.
and the flares are come.
Well, effectively, you've got
They
the
originate between the two.
essentially, yes, because they're in the magnetic field, and the plasma that's around, that's held into that arc, if you like, that will just be when the magnetic fluxes, when they ping, they're literally flung out. But you can see it in H alpha because you can see the plasma getting hot.
Good, lovely, yeah. Thank you.